Hey everyone, it's Justin again. In the last video, we learned how to write the recursive formula for a geometric sequence. So in this video, we're going to be discussing the explicit formula. For geometric sequences, the explicit formula looks like this. As usual, this means any term, and this means the initial term. We learned previously that R is the common ratio, similar to the common difference in arithmetic sequences. The part next to it is weird though. Why is n-1 in the exponent? Well, think about it this way. In a sequence, you start with a first term. After that first term, you find the second term by taking the first term and then multiplying it by the common ratio. For the third term, we take what we got from the second term and we multiply it by r again. And for the fourth term, we multiply that by another r. Notice the amount of r's that we're using each time. For the fourth term, we multiplied by r 3 times. For the third term, there were 2 r's. For the second term, only 1 r. And for the first term, no r's at all. So every time, the amount of times you multiply by r is 1 less than the term number you're trying to find, n-1. For example, here's a sequence where the first term is 3 and the common ratio is 2. Notice how the first term isn't multiplied by any 2's. The second term uses a single 2. The third term uses 2 2's, so on and so on. So the number of times 2 is being multiplied is always 1 less than the number of the term we're on. We'll look more at this in the next video. Let's do some examples. Remember, the n's depend on what term you're on. So the only pieces we need to figure out are the first term and the common ratio. The first term in this sequence is 5. To find the common ratio, we can divide each term by the term before it. 20 divided by 5 is 4. 80 divided by 20 is 4. And 320 divided by 80 is 4. So it's pretty obvious that the common ratio is 4 for this sequence. With these pieces, we can complete the formula. The initial term is 5, and the common ratio is 4. Our next sequence begins with 6, -12, 24, -48, on and on. The first term in this sequence is 6. And for the common ratio, -12 divided by 6 is -2. And it's pretty easy to tell that it's the same to go from -12 to 24 and from 24 to 48. The common ratio is -2. Now we've got everything we need. The initial term is 6 and the common ratio is -2. We need to be careful here though. The negative is part of the ratio, so we need to make sure it's included underneath the exponent. We can put parentheses around -2 to make sure that we don't forget about the negative when we eventually go to use this formula. Pause the video and try this one yourself, but be warned, it's a tricky one. Let's check your answer. The first term is 729, and if we do the dividing trick, we get a common ratio of 2/3. So then the explicit formula for any term in the sequence is 729 times 2/3 to an exponent of the term number -1. The recursive and explicit formulas use the same pieces, the first term and the common ratio, just in slightly different ways. In the next video, you're going to learn how to use the 2 different formulas to write out the whole sequence, or to find one specific term within the sequence. See you then.